Hi, boys and girls. I'm Mr. Rivero's twin brother, Juan Rivero. I'm here to help you out with some translations and dilations of absolute value functions. You guys ready? Here we go. What we have here is the absolute value parent function. Y equals the absolute value of x. Now, you can plug in a bunch of x values and get a bunch of y values back. What you find is all those points will basically line up on this line here. Okay? Just like that. Okay? Now, let's take a look at this. Y equals a times the absolute value of b times x minus h, and then you have plus k. Now we have a bunch of different letters because they represent different things that we can do to the absolute value graph. We'll start with k. Okay, this plus k, as you can see, is on the outside of the absolute value symbols. What this k does is it shifts the graph either up or down. So if it's plus k, this graph is going to shift up k value, whatever k is. If it's a minus k, it's going to shift the graph down, whatever value k is. The next one is h. H is, in this case, it's x minus h, and this h shifts left or right, shifts the graph left or right. In this case, it says that it's minus h, so therefore, if it's minus h, it actually does the opposite. You would think minus would go this way. No, it goes this way. Minus h means it shifts to the right, whatever h value is. And if it was a x plus h, it would actually shift h to the left, whatever value h is. The next one is the b value here. Now you're timesing this by x, and this b value actually makes the v either narrow or wider. So if it's something like a value larger than 1, your v goes inward. If it's a value less than 1, for example half, it will make your v wider. Okay? The last one we have here is a. And what a does is it actually does the same thing as b. It actually make it narrower or wider again. The only thing about the a is that it's outside the absolute value signs. So therefore, if a is a negative number, a does this. It flips your absolute value over the x-axis. Now, let's look at all of these separately so we get a better idea. Now I put shift up or down, and once again I started with y equals to the absolute value of x. I use this because this, once again, this is the parent function, right? The original function, y equals the absolute value of x. Now what I have highlighted here is a plus 3 and a negative 3. Okay, we're taking y equals the absolute value of x and we're adding 3. So if this is the parent function, we do plus 3, you move it 1, 2, 3. Okay? And if you have, this is the parent function again, and it says y is equal to the absolute value of x minus 3, you move it down 3. 1, 2, 3. Let's look at the h values. Now, h, as we said before, was inside the absolute values. Once again, we'll start with the black. The black, once again, is the parent function, right? Y equals x, the absolute value of x. Now, the plus 3 and the minus 3 this time are on the inside of the absolute value lines. Like I said, if it's plus 3, it shifts to the left. It goes the opposite. It goes 1, 2, 3. It goes in the negative direction. And let's go back to the parent function, and it says if inside the absolute value it says x minus 3, then you move to the right. 3 times 1, 2, 3. Alright, let's move on. Wide or narrow? Now this is when we have a value times the x. Once again, the black is again the parent function. Y is equal to the absolute value of x. But this time we're highlighting the number we put in front of the x. In this case, we put a times. We're timesing it by 2. Okay, so what that does is it actually starts here, and then it makes it into a it narrows your absolute value. It makes the V-shape skinnier. The next one is if we were to do something less than 1. This was more than 1. Less than 1 is half. If this is the parent function, it actually makes the V-shape wider. And let's look at the very last one. We said the A value. Now, what you can see about the A value is that the A value is on the outside of the absolute value lines. It's still multiplying by the x, but it's on the outside. And once again, we have the black one. The black is the parent function again. And if you times it by 2, the same thing happens. It narrows the V. It makes it skinnier. And if you times it by something less than 1, for example, half, it once again makes it wider. Now, what is the difference between this A value and the B value we just saw earlier? The A value is on the outside of the absolute value bar. So for example, if you have a negative A value, it then flips this parent function. It flips it over the x-axis. Tomorrow in class, this will be your bell work. We'll see if you can find this. Can you translate the absolute value, the parent function, to phi y is equal to negative the absolute value of 3 times x minus 1 plus 3. Good night, boys and girls.